This example, how many numbers less than 5,000 can be formed using some or all of the integers with no digits being repeated. This example illustrates the use of breaking the problem down into cases. Look, if you want a number that's less than 5,000 and with all the 1457, they did not mention that it must be 4-digit number. So it could be 5, 74, 154, 4751. So if you want a 1-digit number, the way you treat the problem is slightly different from is a 2-digit number. So this is an example that you will consider cases. Consider the separate cases. Then it's easier to solve the problem. So let's consider 1 digit, 2 digit, 3 digit, 4 digits. Then we can solve the problem. So what if it's a 1 digit? No problem. 1457. You can either have number 1, number 4, number 5, or number 7. So easy. 4 cases done. For number of ways 4. What if you want 2 digits? 2 digits, you could use, say, first digit. There are actually 4 different ways because it could 1, 4, 5, 7. The second digit cannot be the same, no digit being repeated. So it must be 4 times 3. Correct? Alternatively, you could say this 4p2. It's the same. Alright, you could say 4p2 as well. 3 digits, same thing. 4 times 3 times 2 because it could be 4 ways. 3 ways, 2 ways. Alternatively, you could say 4p32. Not a problem. Now, if it's a 4 digit, you must be extra careful because of this word here. It must be less than 5,000. So your first digit cannot be a 5. First digit also cannot be a 7. So what is dangerous, you cannot say 4p4. This is wrong. You cannot say 4 factorial. 4 factorial also wrong. Why? Because when you say 4 factorial, you are saying that the first digit could be can be anything. It could be 1, 4, 5, 7. So let's be very careful with that first digit. So therefore, you can't use your 4p4. You can't use your 4 factorial. So your first digit must only be 2 ways. Why? It can only be either a 1 or a 4. Right? After you have chosen 1 or the 4, the second digit can be anything that you have not chosen. 3 times 2 times 1. Therefore, it is a 12. So what about it? So the total number of ways, now since we have divided into 4 separate cases, is the cases, number of ways that, and you add them all up. The reason why you add them all up is because they are all mutually exclusive. Because if you get a first 1-digit number, you won't get a 2-digit number, you won't get a 3-digit number. So all these cases are all mutually exclusive. Correct? Mutually exclusive. Therefore, you can add them all up. Final answer is 52. That's that.